Okay, now Lanang pay to question 3. Question 3 is only organic chemistry. It's all about physical properties. So this question was taken from this question paper on November 2020, and in the description below uzothola links for amanye questions akhona kule question paper. Right, asiqale ke question 3. It's all about physical properties. Right, but in the relationship between boiling point and the number of carbon atoms in a straight chain, molecules of aldehydes, alkanes, and primary alcohols is being investigated. Curves A, now curve A, curve B, now curve B, and C are obtained. So lana masiphe ama-aldehydes. We are not sure what ama-aldehydes A, B, or C. Same goes for ama-alkanes as well as primary alcohols la basiphe wona. Ne? Okay. Right. Lana it seems like sizokhuluma nge-boiling point. The physical property boiling point. Lana basiphe a sketch, basiphe a graph for a boiling point against the number of carbon atoms. So, and then the boiling point is measured in kelvins. Right, with 3.1, but it define the term boiling point. In the description below, I'll also give the definition, but I think it's 3.1 boiling point is what is the temperature at which the vapor pressure is equal to the atmospheric pressure. The temperature at which equals atmospheric pressure. That's our definition for a boiling point. 3.2, write down the structural formula of the functional group of the aldehydes. Aldehydes, we know would contain a carbonyl group. Carbonyl group, it's CO, and there is a double bond in between, and a hydrogen. This is the carbonyl group. That is the carbonyl group. So this is our functional group for aldehyde, and then this functional group we have to sketch ama aldehydes. This group, your functional group, is always found at the end of a chain. So this COH is always found on the end of a homologous series or your structural formula for any given chain yama aldehydes. 3.3. I'm expecting you to so I'm just giving it, I'm just throwing it. I'm answering this question. It's a giveaway, by the way. 1 mark. And then with 3.3, but the graph shows that the boiling point increases the number of carbon atoms. Carbon atom increases. Sorry. So back. If I'm a carbon atoms I3, number of carbon atoms, if I3, let's take C for instance. C, the temperature ibala. Ne? For 4 carbon atoms, you have got the boiling point yenzani, ya increase. For 5 carbon atoms yenzani, ya increase. For 6, ya increase. The temperature keeps on increasing as the number of carbon atoms increases. So there's a direct proportion relationship between the number of carbon atoms as well as the boiling point. Why is that? Batikitilana, the carbon atoms are in a straight chain for the molecules of aldehydes, alkanes, and primary alcohols. Ne? So check, you know what happens again? asithathe, let's say for instance asikhulume ngama-alkanes. Ngama-alkanes sine propanal, 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 methane, alkane, methane, sine-methane, propane, propanal aldehyde. Lana ngifuna ilo kanje, ngidraw ama-alkanes, ne? This is our proper, lena ilo propane le. And then lena propane. See, I just want to make a point by drawing ama sketches, by drawing ama structural formulas. I want to make a point. This is butane, man. Butane. Ngikhuluma ngama-alkanes. Also sinama-alkanes, aldehydes, and primary alcohols. Okay, lena butane. And then I think draw the last one, pentane, pentane again. Pentane, pentane. This is pentane. So 5 carbon atoms, 4, 3. Right. Check agila. Uphinde check in this one. Uphinde check in this one. So I think draw the small, I think draw ama small versions, ama small model versions of lama loganje weight for lama molecules weight. So for a propane and something like this. For a butane, something like this. And then for a pentane, something like this. So I want with the area around lama loganje, lama molecules, increase the more ama carbon atoms are increase, and then the increase of the surface area around lama molecules increase. It also means that the intermolecular forces, the strength of the intermolecular forces increase, because the greater the surface area, the greater the what? The area for bondage. The greater the area for bondage. So therefore, because lama intermolecular forces, in order to break, uzodinga what? More energy. So therefore, that's why in a boiling point increase, because of ama carbon atoms wethu aya stretch, so I provide a more contact or more surface area, and the greater the surface area, the greater the strength of the intermolecular forces. Now to answer 3.3, singathi you don't have to draw this. I'm just giving you a detailed explanation. So we answer it together. An increase in the number of carbon atoms increases the surface area of molecules. And this increases the strength of intermolecular molecular forces. Therefore, more energy is required to break these bonds, so something along these lines. Intermolecular forces, keyword, surface area, keyword, and then more energy is required, another keyword. So 3 marks. 3 marks. Now we will discuss some physical properties for some organic compounds. Mention lama keywords lawo. It doesn't matter ukuthi uyibeka kanjani, as long as lama keywords akhona in the correct context, therefore uzowathola ama-marks wakho. 3.4 bathini la, identify the curve A, B or C that represents the following compounds with London forces. Okay, siyazi ukuthi ama-London forces are the weakest forces, are the weakest intermolecular forces, or the weakest van der Waals forces. Angithi bese kulandela ini ama-dipole igcine ini ama-hydrogen bonds. So sina something like, okay, check out the image lana, sina ama-van der Waals forces, and under ama-van der Waals forces siyabona ukuthi sinama-London forces, which are the weakest ones. And the weakest ones lapho I include ama compounds, organic compounds with the weakest intermolecular forces, yini ama-alkanes, alkenes nama-alkynes. Then ama compounds with ama-intermediate forces, sithola ama-dipole forces. Lawa ama-dipole forces siwathola kulama compounds la abo-ester, ama-ketones, aldehydes, basically the rest of wonke ama-functional groups except for ama-alcohols nama-carboxylic acids, which is wathola kuphi kuma-hydrogen bonds, which are the strongest ones. So the strong functional groups with the strongest intermolecular forces as isibona lana yini i-alcohol as well as i-carboxylic acid. So therefore siyabona ukuthi lana ngoba according to our statement bathi one of the curves A, B or C, one of them ama-aldehydes, one of them ama-alkanes, the other ones ama-primary alcohol. So therefore it means that sifuna identify which curve A, B or C represents compounds with London forces. I know ukuthi ama-alkanes, based on what we have discussed. I know ukuthi ama-alkanes, but which curve represents ama-alkanes? Check out. It's actually curve C. Should be curve C, because check out. At any given number of carbon atoms, C has a lower boiling point. Yeah. Oh yeah, C has the lowest boiling point. So a compound with the weakest boiling point. Yeah. Okay, a compound with the lowest intermolecular forces strength in ama-London forces, for instance, si expect ukuthi ibe ne low boiling point, but a compound with the strongest intermolecular forces will have the highest boiling point. So therefore it means C is being identified as the compound with London forces. So izoba nani? The lowest boiling point. So this was 3.4.1, 3.4.2. But it's identify the curve that represents ama-aldehydes. Mina ngithi ubani? U-B. Mina I'm saying U-B. Check. C has the lowest boiling point and the weakest what? Intermolecular forces. B has the intermediate what? Intermolecular forces, the intermediate strength of intermolecular forces. So this is dipole, and then A has the strongest intermolecular forces. So the strongest yini, it's definitely alcohol. So what lies between A and B? A and C, it's what? It's B. So therefore it's definitely aldehydes. So therefore B is being identified as aldehydes. Explain the answer manje again. Sorry, singathini nje, singayibeka sithini? Singathini? Okay, but I've already gave away answer. Okay. Aldehydes, singayithi aldehydes have the stronger intermolecular forces than, I'm comparing it to, aldehydes have the stronger intermolecular forces than C. And they will see in alkanes, but weaker. B has the stronger intermolecular forces than C. Sibona the difference of boiling points. A higher boiling point means what? Greater strength intermolecular forces. Low boiling point, weak what? Intermolecular forces. So therefore intermolecular forces ka B, strength sakhona si greater than for C, but weaker than A, which is alcohols. Therefore, therefore aldehydes have the highest, that's not the highest, but higher boiling point. Higher boiling point, higher boiling point maybe than C. Therefore more energy is required to break intermolecular forces. Voila, something along these lines. Lana, it's important to compare between lama compounds to make sense of the answer. Now, use the information in the graph and write down the IUPAC name of the compound with the boiling point of 373 as well. 373 now lana, as move across the graph siyabona ukuthi 373 simthola kuphi kuma aldehydes, which is bani? B. We know that to C yini alkanes lawo, ne? alkanes, and then lana 373 is a boiling point esithola ku-sketch bani ku-curve bani B. So therefore 373 boiling point 373 is it's a compound with how many atoms? Carbon atoms, 4 carbon atoms. So therefore this is butanal. 4 carbon atoms. If you compound in a 4 carbon atoms with a functional group of yama aldehydes, it's definitely butanal. 3.5 1 sorry, IUPAC name, not scat, not structural formula. So it's butanal 3.6. 3.6. Write down the IUPAC name of the compound containing 5 carbon atoms, which is the lowest vapor pressure at any given temperature. Write down the IUPAC name of the compound containing 5 carbon atoms, which has the lowest vapor pressure at any given temperature. Interesting. Okay. Phakathi kwama-alcohols, aldehydes, nama-alkanes, which compound has the lowest vapor pressure? It's the one with the highest it's the one with the strongest intermolecular forces. So in this case, ama-alcohols yiwo anama intermolecular forces are strong kuna wonke way-3. So therefore the one with the strongest intermolecular forces izoba the lowest vapor pressure at any given temperature. So therefore 5 carbon atoms, 1 2 3 4 5, 1 2 3 4 5, 1 2 3 4 5. And siyazi ukuthi ama-alcohols wethu yini? Ama-alcohols wethu ama-primary alcohol. So the carbon atom bonded to the hydroxyl group must be bonded to 1 carbon atom. So therefore a primary alcohol example naila. But isinikeza i-IUPAC name, not the structural formula. Mina just draw for demonstration purposes. This carbon atom will be bonded to only 1 carbon atom. This carbon atom associated with your hydroxyl group must be bonded to only 1 carbon atom in a primary alcohol. So this is a primary alcohol. So naming, counting the number of carbon atoms in the longest chain, 3 4 5. So it's 5 carbon atoms. So sinani sine pentan 1 all, pentan 1 all. 1, why? Because the hydroxyl group is at the first carbon atom. And so when counting your number of atoms, give the lowest number to the highest, give the lowest number to the carbon bonded to the functional group, which is the first carbon atom in this case. So it's pent, the stem, and then the suffix is all. 1 because hydroxyl weight is bonded to the first carbon atom. This is a primary alcohol. So this sums up our video for today. Thanks for watching. Now we enjoyed this video, leave a thumbs up, leave a comment in the comment section, subscribe nangabe umusha. In the description below, please click alama link ubukele lama video amanya khona for this question paper. Thanks for watching. Ngizokubona on one of the videos ozokuwaklickile or any other videos obuyibukela in this channel. Thanks for watching. Bye bye.